The animation we are about to show you is to demonstrate how we intended the smart bins to be used. To begin, the user will place the recyclable inside the center compartment of the machine. Here, there is a camera mounted on the back wall that will identify the type of recyclable that can be disposed. Once the door is closed, the image classification process can begin.
The following figure is the process flow of our TensorFlow image classifier. Before the classifier can be used, we must build it. This starts with connecting the program with our photo directory of glass bottles, plastics, and paper waste, with each category containing over 100 pictures. A popular method for machine learning image classification is with convolutional neural networks, or CNNs. This is because CNNs are very good at accounting for variance, since the features CNNs create are very generalized. But to build CNN ourselves, we will need a ton of images, substantial computing power, and a lot of computer processing time. Therefore, we would use a pre-trained CNN model designed for computer vision called Inception, and in our case, Inception version 3. Inception was built by a Google engineer and trained with over 100,000 images with 1,000 categories. To use Inception for our specific purposes, we had to perform a process called transfer learning, which is in a bare definition applying what Inception has learned from its previous training session into a new training session, essentially retraining the program to identify our images. After retraining the program to transfer learning, the program creates a PROBUF or PB file called retraingraph.pb. This is used by the classifier to classify specifically our categories of images. In TensorFlow, the PROBUF file contains graph definitions as well as the weights of the model. Now we can use our recyclables image classifier. Here we have a picture of a beer bottle we took using our camera. This picture will go into a folder as the input. Now the classifier will attempt to identify the image. The programming includes commands such as getting the final tensor from the retraingraph.pb file previously created, converting the given image JPEG file into a TensorFlow image, and also getting the predictions for the final output. Finally, we get an output image with a label and the percentages confidence, where the label is generated by determining which category the program has the highest percentage confidence in. An additional output in the Python terminal is also given with its other confidences from the program. For our example, we got our input image with the label glass bottle 97.2, showing that the program is 97.2% confident the input image is that of a glass bottle. We also have other confidences included in the terminal output. If the classifier outputs confidence levels for any category greater than 90%, SmartBin recognizes the input as an item of that category. If this threshold is not met, SmartBin will weigh the object using a load cell and attempt a second time to classify. If the object is within the weight range for a plastic bottle and has an object confidence greater than 65% for plastic bottles, the object will be identified as a plastic bottle. If the object is within the weight range for a glass bottle and an object confidence of greater than 65% for glass bottles, it would then be identified as a glass bottle. Since there is too much variation in weight for paper waste, SmartBin only uses the load cell classification method for plastic and glass bottles. Anything not classified would then be registered as general waste, and the general waste bin will open. Although the training of the classifier may take a couple of minutes, after it is trained, the classifier can output its confidences in a matter of seconds. That is the summary of the training and usage of our image classifier. It is worth noting that the training program and the classifying program are both open source programs built by Google.
Now that the recyclable has been identified, an LED on the front of the machine turns green, signifying which bin the recyclable belongs to. In this case, it is glass. The user can now remove the recyclable from the center compartment. A solenoid is now energized and unlocks the lid to the correct bin, which initiates a linear actuator to open the lid for the user automatically. Thus, the user can now dispose of the bottle properly. This process can be explained by the following circuit simulation.
The controls for the smart bin operate by using an Arduino Uno to systematically energize then de-energize solenoids and linear actuators. This simulation was produced using Tinkercad and unfortunately was unable to simulate a few components in our design. The linear actuators are substituted by DC motors, and the inductive coils represent the solenoids. The push buttons above represent digital input that would be produced from the sensors, i.e. the load cell and the camera. In this example, a glass bottle was placed into the sensing unit. Push button 3 represents the digital input from the camera and the load cell. The signal triggers the Arduino to energize the solenoid and the green LED for the corresponding bin. The linear actuator, or in this case the DC motor, is energized in a positive direction, and after an amount of time it de-energizes, going in the opposite direction. This represents the opening and closing of the smart bin lid.
Lastly, there are doors located on the front of the machine which gives access to maintenance staff to empty out the bins once they have become full. This concludes our smart bin walkthrough. Thank you.